Okay, welcome to my digital simulation. Okay, let's start with my simulation actually. So we are going to explore how we can turn a simple digital simulation into a powerful education tool, especially in a classroom that you don't have many resources. We will be using water pollution simulation as our example, a fantastic way to bring complex environmental science to life. Okay, let's acknowledge the challenge in classroom, access to expensive lab equipment, chemical, field trip opportunities, and how do you teach about a topic like water pollution without being test water sample and visit a polluted river. This is where digital simulation become game changer. Our simulation as I'm moving right now is called what? It's called Aqua Guidance. It's called what? It's called Aqua Guidance. It's in action based games like a game. You can see right now. I got in my side. I got a special legend which is oil spill, healthy fish, plastics, sedimental, microplastic, coral reef, chemicals, and krill and sedimental. Then the other side I got pollution sources actually. The pollution sources is what cause pollution actually. You see, then I got my fishes. You can see my fishes are going all over around actually. Okay, right now let's start with my simulation then and show how it work. You see, I will use industrial discharge rate to see how whenever I'm increasing the industrial discharge rate, how it work. Then plastic waste input, and it even tell you aside there in the ecosystem health that there is a water quality index which is decreasing in percentage. There's a marine life, meaning the marine life health, meaning the fishes life, all those animals that live underwater. You can see their lives are under danger actually. So our mission, it's like I can say it's like our it's not a passive video actually. It's a tool where learners active participate. You see, they can active participant here. They can control this thing. They can move it. There's the agricultural turn-off. There's the microplastics. You can even clean it, deploy a cleanup crew. You see how it is. Okay. The game show is a visual body of water that can be polluted with different substances like oil, plastic, and chemical runoff. Like I said before, each one. You see, can be can be polluted by a lot of things. As like it indicate on the alert active alert. It see that now the water quality, the water quality is dangerous, is low, and the marine life health is critical. Actually, you see, okay? The learners put in control of cleanup crew with a various tools to tackle the pollution. Now let's break down the subject knowledge this simulation cover. It's more than just a game. It is a type of pollutants. The simulation visual distinguishes between the insoluble substances like plastic, oil, which float and easy to see. Soluble substances like chemical runoff, which like which dissolve, which dissolve, harder to track and teaches learners that not all pollution are what are visible. Like here, there is oil. It teaches that oil is not visible. You see how oil it is. They gave us how oil it is. See how oil it is. It's visible. Okay, now it's fine. Let me just deploy and activate oil schema. Now I'm activating oil schema, which is a cleanup research. Then I deploy what? I deploy a cleanup crew. A cleanup crew is doing what? It's cleaning what? It's cleaning my water. Like it's meaning it's cleaning what? Cleaning the pollution sources actually. The plastic, the agricultural runoff, the plastic weeds. Whenever I decrease my agricultural runoff, it goes down. Then the plastic input goes down. Then industrial discharge, you'll see what's gonna happen in my ecosystem. And you see now the water quality is 0%, meaning there's a lot of pollution like affecting what? Affecting our system, these things. Then we go to the oil spill frequency. I'm decreasing it. You see by weekly, the more there's a less of pollution sources, is the more the water quality index is become healthy and the marine life they become. You see now all of those animals, all of them they are dead. All of them kill all them. The marine life they are dead now. I'm deploying a cleanup crew. My water quality will come back, but the marine life is dead. Meaning now we don't have food to eat. Okay. The type of pollutant the simulation visual takes place between insoluble substances like plastic, oil, which float are easy to see. Soluble substances like chemical runoff, which dissolve are harder to track. This teaches learners that it's not all pollution is visible. Learners learn the pollution come from different sources. They will see visual factors. Pipe causing chemical waste, you see, they see visible factors actually, you see. Okay, a farm causing agricultural runoff. You see, there's a farm causing agricultural runoff, and a city error introducing plastic waste. Okay, causes and effects. The estimation directly link pollution its consequences as the pollution level rise. The in-game indicator for marine life healthy biodiversity decrease. Learners see a direct cause and effect relationship. If you don't clean up the oil, the fish pollution drops. You see, if like you don't clean up what the oil, the fish pollution what now zero because I didn't clean up zero because I couldn't able what to clean up the job. So the crucial concept in ecology scientific method by using tools like the research room to scan for invisible chemical pollutants, learners are introduced to the idea of scientific investigation. They must first analyze the problem before they can solve it. It's like I'm meeting the learner's needs, right? How does this simulation meet the learner's needs of our learners? Learners aren't just listening to a teacher or reading a book. They are doing, they are performing just like I'm doing right now. They are doing something, they are performing something like I'm doing. They can see that there's an effect, there's something. Okay, let me just restart it from reset it. You see, now it's pause. You can even control it. Then as they can control it, they can control the life of the marines. They control the quality of the water. You see, they see the results of their actions and the problem solving in hand ways. This particular effective that learners who learn the best by engaging with material, visual, kinetic learning, the vibrant visual of submission appear to visual learners. The action-based interactive nature is moving clean up the boat deploying tools. It simplifies concept, abstract concept. A real oil is spilled is dangerous, difficult to understand. But a visual oil leak is safe and manageable problem that learners can take without a risk, making the science behind it accessible. Its risk-free environment of exploration and accessibility. The best part, the simulation can run on a single computer. The best part, this one can run in a single computer and it can even run without a Wi-Fi. It doesn't need a Wi-Fi connection or a data. Even in a basic project, it makes perfect for ill resource classroom. The entire class can watch, participate as one learner control. The entire class can watch as like one learner control it actually. Okay. Finally, let's talk about the assessment. How does this learn from? Okay, here is the assessment activity that we can develop it around. Okay, I'll present you with a new polluted run of simulation. This time there is a mix of oil, plastic, and non-chemical. Your mission is to write one page report outline new cleanup and the report included. Okay, then to explain, to choose this tool, I choose the research tool because it's the only tool that can detect invisible chemical pollutants. Why this work as assessment? It beyond simple multiple choices. It requires learners to think critically and apply their knowledge. The report formal assessment, the ability to communicate scientific finding, the clear logical, it proves they understand the causal relationship and the strategical use of tool learning simulations.